Hello friends, welcome to my YouTube channel where I want us to look at this problem. So this problem says that an FM radio station broadcasts at 87.5 MHz, that's our frequency. Then I want to calculate the wavelength of the corresponding radio waves. So these are waves, and we know how waves are. So we have that the speed of the wave is given as its wavelength times the frequency that it has. So what we are given here is simply the frequency, and we're taught to find the wavelength. So the frequency that we have is 87.5 MHz, as you can see there. Now this one is not in standard units, so we need to change it. Now what we know is that a mega, which is a prefix, is simply 1,000,000 times than the standard unit which we have which is the hertz. So meaning that to obtain hertz as the unit for frequency, we're going to get what we have, which is 87.5, to multiply it with 1,000,000, which is 10 to the power 6. Then this is what we're going to get in hertz. Now this one is just the same as 87,500,000. Same as 87,500,000, like that. Now this is in hertz. Okay, now what we have here is that the frequency which is just obtained. Now this same speed is simply the speed of light in vacuum. I do not say light is simply a wave. So in this case we're going to look at the speed of light in vacuum, which is a constant we know as 3 times 10 to the power 8 meters per second. Now the speed of light and the frequency are both expressed in units, in their standard units, so we can now find our wavelength. Okay, so I will erase all this to create more space for my solutions. Now since I'm looking for the wavelength, I'm going to make it subject to the formula. So I divide by frequency both sides, giving me the wavelength to be the speed of light V over the frequency. So my lambda, which is the wavelength, to be equal to the speed of light is 3 times 10 to the power 8 over my frequency, which is 87,500,000 hertz. Now what we need to know is that hertz is the same as the inverse of a second, meaning that we have hertz to be equivalent to seconds to the power -1. So there I can replace seconds to the power -1, such that the second on top cancel the second down, only leaving with meters, and upon dividing I get a 3.43 meters as the solution for my problem.